Hi everyone, my name is Sarah Stromness and this is my Science Brain Activity 1 presentation and it is on escalator work. So what is work? Well, in physics, work is the product of the net force on the displacement of an object. For work to be happening, there's a few things that need to be happening too. The object has to be moving from one place to another and the force needs to be applied to the object. So for objects to be moving locations, it's like if an object was to move from point A to point B. So what is an escalator? An escalator, here's a picture of an escalator. An escalator is like a moving staircase, kind of like an elevator, except moving staircase instead. So here's a little diagram I made for my example later on. This is the escalator, and we're going to be dealing with the vertical component, which is shown on the right, and that is going to be, for my example, it's going to be 12 feet. So how to find work? To find work, you use the equation work equals force times the displacement. And that is when the force and the displacement are going in the same direction. In order to counteract the gravitational pull, the escalator must exert the same upward force on the individual. For instance, if they weighed 100 pounds, the escalator must exert 100 pounds of upward force on the individual riding the escalator in order to move the person upward. Therefore, the force is the weight of the person. The relevant displacement for the problem is the vertical component of the displacement, which I showed you earlier. This is due to the fact the escalator is moving the person upward against the force of gravity. In the horizontal direction, there likely is no significant opposing forces other than the friction of the air. For instance, if one story of the building is 12 feet tall, then the vertical component of the displacement would be 12 feet as well. Next, we will substitute these numbers into the equation. So first, we have work, which is force times displacement. So work is going to be the weight of the person times the distance that is 1 story tall. For example, if the person weighed 100 pounds and the story is 12 feet, then the work is going to be 100 pounds times 12 feet, which is equal to 1,200 foot-pounds. For my second example, we are assuming that the person has 60 kilograms of mass and that the acceleration of gravity is 9.8 meters per second squared, and we're assuming that a story is 5 meters. So work is the weight of the person times the displacement. So work is going to be 60 kilograms, which is the mass of the individual, times 9.8 meters per second squared, which is the acceleration of gravity, times 5 meters, which is how tall which is the vertical component of the story. So then work is going to be equal to 588 newtons times 5 meters. And then that will be equal to 2,940 newtons times meters, which is 2,940 joules.